In this lecture, we're going to review how a star's mass determines its life story and how the lives of stars in binary systems are different from single stars. We've already discussed the importance of a star's birth mass in stellar evolution, but we've so far treated stars as if they were all single systems, even though nearly half the stars in the Milky Way are actually binary star systems. First, we'll summarize the lives of low, intermediate, and high mass stars, and then we'll take a look at what happens when a star has a companion. The star's birth mass determines its evolution because that mass governs how nuclear fusion proceeds in the core. Fusion happens relatively slowly in low-mass stars, and these stars cannot produce elements much heavier than carbon. Low-mass stars live long lives and die as planetary nebulae, leaving behind white dwarfs composed mostly of carbon. Fusion reactions happen a bit faster in intermediate mass stars, but still these stars never manage to make iron. Like low-mass stars, they die as planetary nebulae, but they leave behind white dwarfs that can contain elements heavier than carbon. In high-mass stars, fusion proceeds very quickly, eventually leading to the production of iron. When a high-mass star runs out of fuel, it explodes as a supernova, leaving behind a neutron star or a black hole. In general, stars in binary systems proceed from birth to death as if they were isolated. However, exceptions can occur if the binary stars are close to one another. Algol, the demon star in the constellation of Perseus, is such a system. In mythology, Perseus slayed Medusa, and the star Algol represents the eye of Medusa. Algol appears as a single star to our eyes in telescopes, but it's actually an eclipsing binary star system. As the two stars orbit each other, we see the brightness of the pair vary. When the two stars are next to one another, the pair is the brightest. When one star eclipses the other, the system appears to dim. From our perspective, the star system winks on and off over the period of a few days. The stars orbit closely. The larger companion is a 3.7 solar mass main sequence star, and the smaller is a 0.8 solar mass subgiant. If we think about this for a moment, we realize there's something wrong with the situation. Here's the thing. Binary stars are born at the same time, and therefore both stars must be the same age. We know that more massive stars live shorter lives, and therefore a more massive star must become a subgiant before the less massive star does. How then can Algol's less massive star be a subgiant while the more massive star is still on the main sequence? The resolution to the Algol paradox lies in mass exchange. The 0.8 solar mass subgiant actually used to be the more massive star. As the more massive star, it was the first to begin expanding into a red giant. The stars orbit close enough so that as the originally more massive star expanded, it transferred so much of its matter onto its companion that now the companion is the more massive star. The 3.7 solar mass star is still gaining mass from its subgiant companion. Millions of years from now, it will run out of hydrogen and begin to expand into a red giant itself. At that point, it can begin to transfer mass back to its companion. That's it for Chapter 17 and the lives of low mass and high mass stars. In the next chapter, we'll talk in more detail about the bizarre objects the stars leave behind.